Hello and welcome to my channel. In this video we will be discussing about shear force diagram of cantilever. What is shear force and how to draw the shear force diagram of cantilever. So first of all we will discuss what is shear force. It is the sum of all the vertical forces, all the vertical forces acting either left of the section or right of the section. So we have to consider all the vertical forces acting either left of the section, either we should consider left of the section or right of the section. Any one we have to choose, either we have to take left of a section or right of a section and sum all the vertical forces algebraically to get the shear force at that section. So how this definition will help us in finding the shear force acting on a cantilever. We will discuss this. So we have a cantilever and there is a vertical force acting on it. Suppose this is a cantilever and there is a vertical force acting on it. So how we can draw the shear force diagram? This is the fixed end and this is the free end. In case of cantilever we start from the free end because at fixed end we have support reactions, horizontal, vertical and movement which we don't know in advance. So we will start with the free end. So as discussed in the definition, that if we want a shear force at any section, then we have to find sum of all the forces either left of the section or right of the section. So suppose this is point A, this is point B. So we are starting from the free end. So suppose at a very small distance x from this section, we want to know the shear force. This is the section XX at a distance x from the end B or free end. So this is X section. So we are standing here with our both hands straight. This is our left hand, this is our right hand. On the right we don't know the forces, so it will be useless. So we can say that we have to concentrate only towards the left. So when we see towards our left hand, only one vertical force is seen, that is this. So section between B and A के बीच में कोई सेक्शन है, तो shear force at any section XX वो जो है इस फोर्स के बराबर होगी. सपोज करिए ये 10 किलो न्यूटन है तो सिर्फ एक वर्टिकल फोर्स है. सो देयर इज ओनली वन वर्टिकल फोर्स हियर. सो वी हैव दिस shear force 10 किलो न्यूटन हियर because only one vertical force is there. So we have this. If we move this section to this location somewhere here, then also we are standing here seeing towards our left, then only this force will be seen again. So the shear force will remain 10 kilonewton. And if we move to this point A, then also if we stand at this point A and see towards our left, only one force will be seen. So the shear force at A will also be equal to 10 kilonewton. So the shear force has remained constant from point B to point A if there is a single point load acting on the cantilever. So we can draw the shear force diagram. This is point A and this is point B. At all the places we got the shear force as 10 kilonewton. So we can simply draw this type of shear force diagram, which is 10 kilonewton at every section. And now if we complicate it little bit, we use 2-point loads, then how it will change. So again we are having a cantilever. This is point B, this is point A, this is point C. So here at point B we have a 10 kilonewton load, and again at point A we are having a 20 kilonewton load, suppose. Then how we will find the shear force at each section? So again we will start from the free end. Suppose a section between B and A, XX section, this is at a distance x from B end. Then section between B and shear force will be at any point at section XX will be equal to, when we are standing here, if we are standing here and seeing towards our left, only one vertical force will be seen towards the left, that is this 10 kilonewton. So the shear force will be 10 kilonewton. If we move this section to the point A, just here we are standing, then again we will see only one force. So the shear force at point A will be again be equal to 10 kilonewton. But as we move the section between A and C, now the section has come up here, or suppose just beyond A. First of all we can consider it here at this point beyond A. So we are standing here, we see towards our left, so two forces will be seen, one force this 20 kilonewton and one force this one 10 kilonewton. So these two forces will be there. So the shear force at section XX will be equal to this force plus this force. But these two forces, both the forces are in downward direction, and we are considering downward direction as positive. So we can say 20 plus 10, so 30 kilonewton. Now we can move this section to this point, just point C. So if a person is standing here, he stretches his left hand towards this direction and sees towards his left. So again he will be seeing these two forces, this one 20 kilonewton force and the other this 10 kilonewton force. So the shear force at point C will again be equal to 20 plus 10, that is 30 kilonewton. So now again we can draw this shear force diagram for this cantilever. So this is C, this is A, and this is B. Between B and A at every point we have a shear force equal to 10 kilonewton. So it will be at B and A, between B and A, it will be constant 10 kilonewton. At this junction at A, just before A we have a 10 kilonewton, just after A we have 30 kilonewton. So it will be like this, and then it remains constant till C, that is 30 kilonewton. So in this way we can draw the shear force diagram for this case. This will be 30 kilonewton shear force and this will be 10 kilonewton. That is between section B and A. Between B and A, shear force is 10 kilonewton, and between the section A and C, the shear force has remained 30 kilonewton, which is constant. Therefore, this line is also constant. Next, we will see how to draw the shear force diagram of cantilever when there is uniformly distributed load, and how this shear force diagram, the shape of shear force diagram or the slope of shear force diagram tell us that we are drawing a correct shear force diagram or not. That we will discuss in the next video. Thank you for watching our video. Please subscribe to the channel and press the bell icon for notification of next video.